Hi, this is Mr. Nazarian. Our lesson objective today: I can find the dimensions of a rectangular prism with either double or half of the volume of another rectangular prism. 5th grade standard measurements and data, C5. Tatum owns a toy making company. She produced enough toys per day that filled her delivery truck completely full. Her truck's cargo area measured 10 meters long, 4 meters wide, and 6 meters tall. She hired more toy makers and was able to double her toy production. She now needs a cargo truck that can carry twice the volume as before. What could be the dimensions of a truck that can handle her new production volume? So, what we know is the dimensions of her current cargo truck. The cargo area is 10 meters long by 4 meters wide by 6 meters tall. So before we even deal with finding out the volume for this, we will remember that when we are doubling the volume of an original rectangular prism, and the new one is double the volume, all that we need to do is to find a new dimension for the rectangular prism with twice the volume. That's right, we double one of the dimensions. Not all of them, as is a common mistake. We only need to double one of the dimensions. So, for example, if we doubled this dimension, kept the other two the same, we could have 20 meters by 4 meters by 6 meters. If we kept the 10 meters the same, and kept the 6 meters the same, but doubled the 4, then it would be 10 by 8 by 6. If we kept the 10 and the 4 the same, but doubled just this one dimension of the 6, we would have 10 by 4 by 12. Okay, well that's all well and good, but as mathematicians we need to prove it. So, in order to do that, let's prove and make sure that this strategy works. First, we'll find the volume of the original cargo truck. 10 by 4 by 6. Well, 10 times 4 is 40, and 40 times 6 would be 240 meters cubed. So, in order for these to be true, the dimensions to work for the new cargo truck possibilities, then we need to have a volume of 120 meters cubed, right? Half of the volume. So let's see. 20 times 4 would be, what? 80. And 80 times 6 would be 480 meters cubed. I'm just doing this little up symbol here to show that this is an exponent. Okay, so that worked. That is double the volume. How about this? 10 times 8 is 80 again. 80 times 6 is 480. So 480 meters cubed works again here. And last one, 10 by 4 by 12. 10 times 4 is 40. 40 times 12 is again 480 meters cubed. Okay, so that works. All we need to do to find a new possibility of dimensions for a rectangular prism with twice the volume is to double only one of the dimensions. Got a new one here. How about Justin? He went on a family vacation in Hawaii where he relaxed on a beautiful white sand beach. He wanted to bring home some of the sand. He gathered the sand into a box 15 inches long, 4 inches wide, and 2 inches tall. His mom told him that he could only bring half that amount of sand with them because of storage limitations on the plane. What could be the dimensions of a box to hold half the amount of sand as Justin had originally planned? Again, let's write out what the dimensions of the original box was. It was 15 inches long by 4 inches wide by 2 inches tall. So, using the same rationale as with doubling the volume, here we're going to half the volume by doing what to the dimensions of the original rectangular prism? Correct, we are going to half one of the dimensions. Now, I could half this 15 and get 7.5, but I'm not going to mess with that now because I don't want to deal with multiplying fractions at this moment. That's something that we're going to work a lot with later in the year. But for now, I'm going to keep that 15 as is. So I'm going to keep the length the same, 15. Remember, I just need to half one of the dimensions anyway. So I'm going to choose to half this 4 of how wide it is. So The length and the height is going to stay the same, 15 and 2. I'm going to keep 2 of the dimensions the same. I'm only going to half one of the dimensions here. So half of 4 is 2. So 15 times 2 times 2 would work. Or if I kept the length and width the same, but halved the height, just one of the dimensions, then I would have 15 by 4 by 1. Again, let's check to make sure this works. 15 times 4 is 60, times 2 would be 120 inches cubed. So let's make sure that these two different dimensions here, or two different choices for dimensions of rectangular prisms, would work. Again, they'll have to have half of the volume. So 15 times 2 is 30. 30 times 2 would be 60. So yes, that worked. And 15 times 4 again was 60. 60 times 1 is 60. So again, that works. So as a reminder, when we are when we want to find a rectangular prism with half the volume of another one, we just need to half one of the dimensions. All right, we are going to work with on word problems using doubling and halving volume tomorrow. See you then.